Hi class, this lecture is going to cover section 2.2, and this lecture is going to be about patterns and inductive reasonings. So we have two objectives in this section. The first one is we want to use pattern to make conjectures, and I'll talk about exactly what conjectures are in a second. And then finally, we want to disprove geometric conjectures using what is called counterexamples. And that'll probably be the most difficult part of this lecture, but I'll try to provide you with a bunch of examples of counterexamples. All right, so what is inductive reasoning? So most learning occurs through what we call inductive reasoning, and this is making generalizations from observed patterns in data. All right, so let me show you some examples of inductive reasoning and forming, generalizations from observed patterns. So this one here, describe how to sketch the fourth figure, then sketch it. So it looks like I have this circle, it's cut in half, and then that one's cut in half, right? And then it's weird. And then it looks like here it goes from 2, 4 to 1, 2, 3, 4, 5, 6 pieces of the pie. All right. Well, each circle is divided into twice as many that there were, right? So many equal regions as the figure numbered, right? The fourth figure should be divided into eighths, right? And the section just above the horizontal segment on the left should be shaded. So I went from 2 sections to 4 sections to 6 sections. So it should be 8 sections, and then the figure here, the bottom one on the left should be shaded. So it should look like this: 1, 2, 3, 4, 5, 6, 7, 8, because there's 8 of them. All right, so let's talk about a sequence and then finding the next term. So if you look at this one, try to figure out what the next term is. Well, you try to look for patterns. So from 6 to 17 is 11. 17 to 28 is 11. 28 to 39 is 11. So 39 and 11 give me 50. Here, kind of use the same idea. What is the pattern here? The difference here is 4, then 4, then 4. So the next one should be 4 as well. So 4 more than 23 is 27. This one here, it looks like instead of going up by 4, this one's going down by 4. So the final term here should be 4 less. Excuse me. And then finally, here it looks like the difference is 2, then the difference is 3, then the difference is 4. So it looks like the next difference should be 5. So 5 more than 11 gives me 16. All right, here. Difference here. So 11 to 16 is 5. Then here, 16 to 22, that's 6. And then 22 to 29 is 7. So the next difference went from 5 to 6 to 7. So this next difference should be 8. So 29 plus 8 give me 37. Let's do another one. Let's describe the pattern and then write the next 3 numbers. Well, this is weird. So it looks like the numbers are getting pretty big pretty quickly. Well, what I notice here is that this one to go from 7 to negative 7 to negative 23 is times 3. And then what do you know? It's the same thing on each side. 3 times negative 21 gets me negative 63, and so on. So all I'm going to do is multiply by 3 to get the next number in the sequence. And as you can see, if I take minus 189 times 3, I get this. And I take minus 567 times 3 to get this. And then I take minus 1701 times 3 to get this. Those are the next 3 numbers in the sequence. All right, let's do everyday conjectures. This is going to be those if-then statements that you're used to seeing. So if I flip the light switch up, then the light will turn on. If I touch the stove while it's on, then I will burn my hand. If then. If then. So here's another example. A scientist dips a platinum wire into a solution containing salt, sodium chloride, passes the wire over a flame, and observes that it produces an orange-yellow flame. She does this with many other solutions that contain salt, right, finding that they all produce an orange-yellow flame. Make a conjecture based on this finding. Well, it seems like something with salt, if I have salt, then I will have a flame. So if a solution contains sodium chloride, salt, then in a flame test, it produces an orange-yellow flame. There you go. All right, what is a conjecture here? All right, a conjecture is a conclusion made based on an observation. What is inductive reasoning? It's a conjecture based on patterns. We've been seeing all these different patterns in the example. All right, proving a conjecture true is very hard. All right? But proving a conjecture false is much easier. So if someone says, hey, I believe this to be true, if you can show a counterexample, proving it false is a lot easier than saying something is true for sure. All right, so what is a counterexample? How do you disprove a conjecture? A counterexample is an example that shows a conjecture is false. Right? And what are the steps for inductive reasoning? And how do you use inductive reasoning? Well, first thing you're going to do is find a pattern. You're going to make a conjecture, and then you're going to test your conjecture, or you're going to find a counterexample that disproves it. All right. Example number 3 here. Let's make and test a conjecture about the sum of any 3 consecutive numbers. So consecutive numbers are numbers that follow one right after each other, like 3, 4, and 5 are consecutive numbers. So here's the thing, if I take 3, 4, and 5 and add them together, I get 12. 6, 7, and 8, I get 21. 8, 9, and 10, I get 27. 11, 12, and 13, I get 36. Well, there's something that I know. 12 is equal to 4 times 3, the middle number. 21 is equal to 7 times 3. 27 is equal to 9 times 3. And 36 is equal to 12 times 3. Huh. So my conjecture, the sum of any 3 consecutive numbers is 3 times the middle number. If you look here, -1 plus 0 plus 1, that's equal to 0. That's equal to the middle number times 3. Huh. Same thing over here, 20 plus 21 plus 22 equals 63. Well, middle number is 21. 63 is 21 times 3. All right, conjecture. Example number 4. Here's a conjecture. The sum of 2 numbers is always greater than the larger number. Is this true or false? Well, you would think, that the sum, if you take 2 numbers, is always greater than the largest number in that sum. Well, look at this. -2 plus 0 is equal to -2. What is the largest number in this? -2 or 0? Well, the largest number is 0. Well, the sum here, -2, this is not greater than the largest number. It's actually less than. So a counterexample was found, so that conjecture is false. So this is not true. The sum of 2 numbers is always greater than the larger number. False. So inductive reasoning, again, look for a pattern, make a conjecture, prove the conjecture, or find a counterexample. Example number 5. Let's do another counterexample. Show that this conjecture is false by finding a counterexample. For every integer n, integers are numbers like -2, -1, 0, 1, and 2. N to the 3rd power is positive. Well, pick integers and subtract them into the expression to see if substitute them, into the expression to see if the conjecture holds. Well, if you let n equal 1, all right, plugging that in, n cubed is equal to 1, so 1 is greater than 0, the conjecture holds, it's positive. But if you do -3, -3 cubed is -27. -27 is less than 0, so it's not positive, it's negative. So the conjecture is false by this counterexample. All right, and n is equal to -3 is the counterexample. All right, again, show the conjecture is false by finding a counterexample. 2 complementary angles are not congruent. All right, well, remember, complementary angles sum up to 90, and congruent means they're equal. So I'm saying if 2 angles sum up to 90, there's no way they can be equal. But if you take 45 plus 45, these are congruent angles. Right? When you add them together, they get 90, so that's complementary. So if the 2 congruent angles both measure 45 degrees, the conjecture here, the conjecture being 2 complementary angles are not congruent, is false. All right, again, show the conjecture is false by finding a counterexample. The monthly high temperature in Miami is never 90 degrees Fahrenheit for 2 months in a row. So I've got this chart here that shows the monthly high temperatures in Miami. Well, if you look here, all right, the monthly high temperatures in January and February, 2 months in a row, were both less than 90 degrees, so the conjecture is false. Again, show that conjecture is false by finding a counterexample. For any real number x, if you square it, that's going to be always greater than or equal to x. It seems like that should be true, and generally it is true for any integers. But if we pick a fraction, all right, so if we let x equal 1/2, if you square 1/2, you get 1/4, and 1/4 is not greater than or equal to 1/2. So the square of it is not greater than or equal to the original number. So this conjecture here is false by a counterexample. Again, let's show that the conjecture is false by finding a counterexample. Supplementary angles are adjacent. Well, remember, supplementary angles only need to add up to 180. If you look at these two degrees, 23 and 157. They add up to 180. They are not adjacent. Okay, so these supplementary angles are not adjacent, so the conjecture is false. Again, show the counterexample is false for finding a counterexample. The radius of every planet in the solar system is less than 50 kilometers, or excuse me, 50,000 kilometers. Well, so here I have the planet's diameters. Right, remember the radius though is half of this. Well, if you look here, if you were to divide Jupiter and Saturn in half, the radius is half the diameter. So the radius of Jupiter is 71,500 kilometers, and the radius of Saturn is 60,500 kilometers. So this conjecture is false, right? That every planet in the solar system has a radius less than 50,000 kilometers.